What's up, everyone? So, on this series, we are going to talk about the current state of Apollo Cache and how you can interact with it under different circumstances. The end goal of this is to give you a more refined control over your cache. This is particularly useful for situations in which you have restrictions from reaching for the server because of network limitations or lack of server processing power for dealing with the required amount of requests. So in these cases, you want to increase your cache hit rate as much as possible. And that's when a custom configuration might come in handy. For this tutorial, I have prepared an application that implements these different scenarios that we are going to discuss. A link to the repository is listed down in the description. And the way this is going to work is with me doing a code walkthrough on the project, explaining what I have done and the reasoning behind each part of the code. But before we get into it, let's first talk about what happens to Apollo cache after a mutation gets fired. What happens to the cache depends primarily on how your data is actually stored. And by that I mean that we can face two different scenarios. You can either have normalized data in your cache already, or you can have unnormalized data in your cache. Now, if the latter is your case, I have a single very important suggestion to you, and that is to work around ways to normalize your data. Although this is not mandatory when working with Apollo, it will make your life so much easier because you will be able to leverage the true power that the library brings built in by default. Later on this series, I'm going to explain how to deal with this unnormalized data situation. But for now, let's focus on normalized cache data. Knowing that your cache data is normalized, we gotta analyze the mutation's return. If it returns the same type of object that you sent, but with the updated fields, Apollo is able to identify that entity in the cache and update it with that newly received data. This saves tons of network requests because there will be no need to refetch queries that depend upon that object, as their results are going to be automatically updated with the new cached data. Although this is the default behavior, it is possible to disable it by passing an attribute telling the mutation not to broadcast the changes it makes to the cache to other queries. Now, if the mutation returns a different type, a boolean for instance, Apollo is not able to automatically identify that object. So we gotta give it a little help by creating an update function that tells Apollo what to do with that newly received data. And that's it for this introduction video. I hope it has given you a good glimpse of what we are going to talk about in the upcoming ones. So I see you in the next one. Peace.